Hello, this is Mr. Craig, and I want to make another video over the polyatomics where you add an oxygen, remove an oxygen, or remove two oxygens. So these are naming ionic compounds, dealing with polyatomics, but with these exceptions. Now, first of all, hopefully you have your 10 polyatomics memorized, and if you don't, then you need to, and again, I highly recommend that you remember your polyatomics by making flashcards. And if you don't remember the polyatomics, let's go through them real quickly here. So we've got acetate, which is C2H3O2 with a -1 charge, and that's acetate. You have nitrate, which is NO3 with a -1 charge. You also have iodate with a -1 charge, and these may not be in order. Hydroxide with a -1 charge. Chlorate, ClO3 with a -1 charge. And those are your 5 that you have a -1 charge with. Then you have sulfate with SO4 with a -2 charge. You also have chromate, CrO4 with a -2 charge. I think that's it. Oh, carbonate with a -2 charge. And those are our 3 that have -2 charges. And then you have your -3 charged particle, which is phosphate, PO4 with a -3 charge. And then our one and only positively charged polyatomic, which is ammonium. And again, when they have negative charges, they act like a nonmetal. When they have a positive charge, like ammonium, NH4, we treat that as a metal. So those are your 10 polyatomics that you need to know, especially if you plan on taking AP Chemistry. So acetate, nitrate, iodate, hydroxide, and this is the only one that ends in IDE, okay? Chlorate, sulfate, chromate, carbonate, phosphate, and ammonium. Now I'm going to leave these up on the board here because I want to go over these rules quickly. If it ends in ITE, has an ITE ending, and none of these have an ITE ending, okay? So if it ends in ITE, the first thing that you should recognize is I've got a polyatomic. Those are your keys. You want to start recognizing things that end. If it ends in IDE, if a compound ends in IDE, you probably have an element, except for this one, hydroxide. This is our only polyatomic that ends in IDE. It's kind of mean, but hey. So most of the time, unless it's hydroxide, and that's why you want to memorize them, unless it's hydroxide, this equals some kind of element, okay? So some non-metal. And if you looked at some of my earlier videos, I talked about the non-metal triangle. Those are what I'm talking about. These are non-metals, okay? Okay? So non-metals, we drop the last syllable or last 2 syllables and add IDE. Okay? That tells you you've got some non-metal element. But if it ends in ATE, okay, these all end in ATE, like acetate, nitrate, iodate, chlorate, sulfate, chromate, carbonate, phosphate. Okay? If it ends in ATE, you are looking at a polyatomic. Okay? This one, ammonium, does not follow these rules. Okay? One less oxygen ends in ITE. Well, the good news is this doesn't even have any oxygens. So when you're looking at the exceptions for using these 3 things right here, ammonium doesn't get to work with this. Okay? Also, there's a couple other polyatomics where we don't get to use these special rules. Top one here, acetate. Acetate's one that we can't take an oxygen away from or add an oxygen to. And we haven't discussed organic chemistry yet. But so acetate will not follow these rules. Okay? So ammonium and acetate. There's also one extra one, hydroxide. Since hydroxide is OH with a -1 charge, and we're going to do a lot with hydroxide later on, so don't get all upset about that. But really, now that takes us from 10 to 7 polyatomics that you have to worry about for these rules here. Okay? All right, so let's get to it. If it has one less oxygen, we call it ITE. If it has two less oxygens, we have what's called hypo, and then we drop the ate and add ite. So we put hypo at the beginning. And when we talk about acids and bases a little bit later on, you're going to find that there's something that sounds a lot like hypo. It's hydro, but we're not going to worry about that right now. Hypo right now simply means that I have two less oxygens than that which I started. But don't forget, you need to also change your ate to ite. And then if I add an oxygen to one of these, okay, then I put a per in front. Now, what I didn't put on the end here, the ate ending still stays intact, okay? So really, that won't change. The per means that we're adding one more oxygen, okay? But the per actually can take place with a lot of other different things. That's why I didn't put the ate on the end of it. Now, probably one of the most important things to realize is if I'm adding an if I'm removing one oxygen or removing two oxygens or adding an oxygen to these polyatomics, okay, it doesn't change the charges. That's huge. It doesn't change the charges. So you don't have to memorize new charges because we're adding and removing an oxygen. Later on, when we talk about oxidation numbers, we'll talk about what the charges for these are, and don't worry about them. Again, non-metal with non-metal, we're not going to worry about charges. But it doesn't change the charges. Okay, that's huge. Let's go ahead and name these. And what we're going to do is we're going to name these and write these out. And what I want you to do is make sure that you have your periodic table available. Whenever you write or work on ionic compounds, you always want to have your periodic table out. Actually, it doesn't matter whenever you're writing any chemical formulas, have your periodic table out. Because I don't expect you to memorize these, and I guarantee or I hope that your teacher doesn't expect you to memorize these either. A lot of information on this periodic table. All right, so looking at this first one, we have Na2CO2. Na is sodium. Okay? So we have sodium. And probably not a bad idea. Let's go ahead and write the charges above, because since these are ionic, we want to make sure the charges balance out. So sodium has a +1 charge. The CO2, what is CO2? Well, from our 10 polyatomics, this is closest to carbonate. But carbonate is CO3 with a -2 charge. So this has one less oxygen than the ate ending. So we have not carbonate, but we have carbonite. Okay? Ends in ite. The charge on carbonite, is a -2. And again, we want to make sure that these all balance out charge-wise. So since this has a -2 charge, this has a +1 charge, that means we should have 2 of those, and we do. Okay? So sodium carbonite. All right, let's look at the next one. We have Pb. Pb is lead. And the reason why we always want to have our periodic table out is so we can always check and see that if a metal has more than one charge, you have to tell me what the charge is on the metal, if it has more than one charge. If it only has a single charge on the periodic table, you do not ever show Roman numerals. So lead, Pb, has a potential charge of either 2 or 4. So we're going to find out which charge it's going to be here in a moment. So looking at nitrite, or nitrate, NO3, well, this has 2 less oxygens, so what convention do we use? If it has 2 less, then we go hypo. So we have hypo, and then since it's nitrate, we drop the ate ending and put ite, so nitrite. Okay, so hypo and ite means that we have 2 less oxygens. Nitrate is NO3 with a -1 charge, and since this has only 1 oxygen, that means we lost 2 of those. So hyponitrite. Now, we have to get the charges right. So looking at the lead, actually let's go back here. Nitrate, or NO3, has a -1 charge, which means that nitrite also has a -1 charge. Now looking at the subscript here, how many nitrites do I have, or hyponitrites do I have? I have 2. So that tells me what my charge on the lead is. Since I only have 1 lead, then the charge on the lead must be +2. Okay, so we always want to balance out the charges. So in this case here I have lead Roman numeral 2 hyponitrite. Okay, always balance charges. All right, let's look at the next one. We have copper, Cu. So let's go ahead and write that. Okay. And then PO3, well, that's close to PO4, which is phosphate, and it has a -3 charge. But since it has one less oxygen, what are we going to call this phosphate? That's right, phosphite. So drop the ATE and put ITE. Okay? Copper phosphite. Now, looking at your periodic table, does copper only have a single charge, or does it have more than one charge? Well, looking on your periodic table, it has a charge of either 2 or 1. I need you to tell me what the charge on this actually is. So we go back to the compound. If we know that phosphate has a -3 charge, then that means phosphite also has a -3 charge. Now here's my question to you. How many phosphites do I have there, or represented there in the equation? That's right, only one, because there's no parentheses. Remember back when we talked about polyatomics, if you need to represent more than one polyatomic, you use parentheses. No parentheses, that means we have only got one. So I have one phosphite and it has a -3 charge. How many coppers do I have? I have 3, therefore the charge on each copper must be +1. So when I come back in here and write my formula name, Roman numeral 1. The Roman numeral represents the charge on each copper metal. So each of these coppers has a +1 charge, where the phosphite has a -3. Okay? All right, let's take a look at the next one. We have calcium, Ca. I don't know why I did that lowercase. Let's do that again. All right, let's take a look at the next one here. We have calcium. Okay, and if I look at calcium on the periodic table, it's in group 2A. It only has a single charge, so that's good. Don't have to worry about putting a Roman numeral on that. And then ClO4. Well, we do have a polyatomic that's ClO3, and it has a -1 charge. This is chlorate. So since we added an oxygen, this is going to be perchlorate. So we put the per in front. Again, it still ends with the ATE ending. We don't change anything about that. The per simply means that we're going to add one more oxygen to our regular polyatomic. The charge remains the same. All right, now, since this has a +2 charge, we should have 2 perchlorates. That's why I have that there. So the perchlorate's -1. The subscript tells me I have 2. All right, let's take a look at this one. Ag2SO2. Well, we know Ag is silver. It's not gold. Remember, there's no G in gold. So we have silver. And then we look at our periodic table. How many different charges does silver have? It only has a single charge, +1. So since it only has a +1 charge, no Roman numeral. Again, Roman numerals are only used for metals that have more than one charge. So there's no Roman numeral. And then SO2 is very, very close to our polyatomic SO4, which is sulfate. And it has a -2 charge. That's why we have 2 silvers. But since we have SO4 and this is SO2, how many oxygens have we taken away? That's right, we've taken away 2. So this will be silver hyposulfite. Okay. So again, the hypo-ite ending, or the hypo prefix, the ite ending here. Okay. So since we have 2 less oxygens in our sulfate, silver hyposulfite. Okay, isn't that cool? Okay, now we're going to go from the name to the symbols, and I think this might be a little bit easier for you. So again, having your periodic table out, nickel is Ni, and it has a +2 charge, so I'm going to write the 2 above it. Again, the Roman numeral tells me what the charge is, and that's really nice because if you have a metal that has more than one charge, you don't need to go to the periodic table and look at the charge. It's there. But if you have something like this where you don't know what the charge is, then you got to have your periodic table available, unless you just want to memorize that. Don't. All right, so we have iodite. Well, I know that iodate is IO3 with a -1, but since it ends in ITE, that means I have 1 less oxygen than my ATE ending. So in this case, it would be IO2, and it has a -1 charge. Okay. Now, we still have to balance these because even though the name charge is balanced, these are not balanced. So I have a +2, a -1. So since I have a 2 there, that means I need 2 here. Also, since I have a polyatomic and I need to represent more than 1, use parentheses, put the 2 there, and that -1 means I have 1 nickel. So there's your nickel, Roman numeral 2, iodide. Potassium, and here we have hypoite. So potassium hypocarbonite, well, potassium is K, and it has a +1 charge, because it's in group 1A. Okay. And then the hypocarbonite, well, I do know that carbonate is CO3 with a -2 charge. So hypocarbonite means that I'm removing how many oxygens from this? That's right, 2. So if I take 2 oxygens off of there, I have CO. Now, the charge, again, remains as a -2 charge. So I want to show that. Okay, so now that I have my metal and my non-metal written down, let's balance these out. Since this has a +1 and that's a -2, again, we're trying to get this algebraic sum to equal 0, that means I need 2 of those, where I only need 1 hypocarbonite. Okay? And if you need to write the values here, okay, like I did in my other video, this, whatever's in the parentheses are my subscripts, and of course we never write a 1 for our subscript. Okay? All right, iron 3 sulfite. All right, we've got another charge here. So the iron is F3, or Fe, sorry, Fe, and it has a +3 charge. How do I know that? Well, I'm telling you that. Also, if you want to check and make sure, iron can either be a +2 or a +3 charge. And then sulfite comes from sulfate. So sulfite means I have 1 less oxygen. So I'm going to go SO3. Charge remains the same at -2. So I want to balance charges out. So if I have a +3, ooh, now we get to really change them up. So if I have a +3, that means I need 2 of those and 3 of those for this whole thing to equal 0. Or even better, if I have a 3 there, I need 3 down here. Now that 3 does not take care of that. We have to use parentheses and show that. And then the 2 here, again, we only put parentheses around the polys. So Fe2 parentheses SO3 with 3 sulfites. That's a good one. I like that one. Zinc hyponitrite. Again, recognizing you have hypo and ite. So zinc, Zn. Now we got to go to our periodic table because I doubt if many of you memorize the name or the charge. Has a +2 charge and only a +2 charge. So we don't use a Roman numeral for that. You never need to. And never show Roman numerals for, again, for metals that only have 1 charge. Hyponitrite, again, nitrite is from nitrate, which is NO3 with a -1 charge. So if I have hyponitrite, that means I'm taking 2 oxygens off of this. So NO, and since it has a -1 charge, that's my basic formula. And then let's balance charges, so I need 2 of those and 1 of those. So parentheses, the NO, because we have a polyatomic, there's your zinc hyponitrite. Getting a little easier? Sodium persulfate. Sodium, Na, and the charge on sodium from your periodic table is +1. Persulfate, ooh, here we go. We have our per, and the 8 tells us, ooh, we don't change the ending of this because the per means we're adding 1 more. So sulfate, which I have right here, sulfate. So if it's persulfate, that means I add 1 more oxygen, which is SO5. And the charge is still -2. So if I have a -2 charge on that, how many sodiums do I need? Very good. 2 of those. So 2 of those and 1 of those. Okay, there's our formula for sodium persulfate. And then gold 3 carbonite. Well, we have carbonate up here. If it ends in just ITE, that means we're taking 1 oxygen away. So 1 oxygen from the carbonate. But let's write gold down first. And what's the symbol for gold? That's right, AU. No G in gold. So gold has a +3 charge. And carbonite is carbonate with 1 less oxygen. So CO2, okay, that's not carbon dioxide, that's carbonite since it's in a compound. And it has a -2 charge, so that means we need 3 of those and 2 of those. parentheses. There's your gold Roman numeral 3 carbonate. Hope this video has helped. I know it's not all of the different types of examples, but if you want to do well on naming compounds, you must memorize your 10 polyatomics, names, formulas, and charge. You have to have those memorized. And then the rules for if we take an oxygen away or not. So you have to have that memorized as well. So 1 less oxygen ends in ite, 2 less, hypo, ite, and then 1 more we added at the beginning of the name, per. And most importantly, the charges do not change. Hope this video has helped.